In this one, we are going to talk on graph models. I'm going to define it in an informal way, that is, an easy or simplified wording to explain something in order to understand. For a proper wording, consult any book from the recommended book list. Before we begin, let us see what kind of graph we can have. Number one is simple graph. In a graph theory, we are only concerned with how nodes are connected via links. If there is only one link between two nodes, then we have a simple graph. For example, V1, V2 are connected via a link E1. In the same way, V2 is connected with V3 via E2. E1 can be written as unordered pair of U comma V1 comma V2. E2 can be written as an ordered pair of V2 comma V3. The graph, here we have a simple graph. The second one we have multi-graph, a graph that is not simple or a graph that has multi-edge. It is called a multi-graph. A multi-edge can be defined or understood by the idea of link or line if the same pair of vertices are connected via more than one link. Then it is called multi-edge. For example, here between V5 and V6 there are E5, E6, E7. Therefore, V5 and V6 are connected by three links, and the graph is a multi-graph. A graph can also have a loop. A vertex that is connected to itself is called a loop. Pseudograph, a graph that contains loop or multi-edge, is called a pseudograph. Number 4 is directed graph. A graph contains directed link or edges. If links are directed, implies the pair of vertices is also ordered. For suppose you have a pair of vertices V1, V2. V1, V2 के दरमियान आपके पास एक डायरेक्टेड लाइन है E1 that goes from V1 to V2. This implies E1 के पास starting प्लस एंडिंग पॉइंट है, that is V1, V2 और V1, V2 ऑर्डर्ड पेयर हो गए, where the order pair of V1, V2 is not equal to the order pair of V2, V1 because V1 is the starting point and here V2 is the ending point. The second one is V2 where V2 is the ending point and here V1 is the starting point. Again आपके पास एक ग्राफ है V1, V2 और between V1 and V2 you have a bi-directed line. That is, it can goes from V1 or it can goes from V2. Therefore, इसमें जो पेयर बनेगा वर्टिसेस का वो अनऑर्डर्ड होगा. A graph which contains bidirected or bidirectional links is called undirected graph. A directed graph can be simple directed graph or it can also be a multigraph. In this example, we have a directed multigraph. क्योंकि अगर आप देखें V1 और V2 के दरमियान दो लिंक्स हैं. The first link goes from V1 to V2. The second link goes from V2 to V1. Therefore, आपके पास यहाँ पे मल्टीग्राफ है और डायरेक्टेड है. In the same way, the graph in figure 3 is also a directed simple graph. Can a graph have both directed and also undirected link? Yes, it can have, and this kind of graph are called mixed graph. In graph theory, it is better to focus on some key aspect rather focusing on words, labels labeled by different authors from different disciplines. The number one is what kind of links do we have? Number two is what kind of graph is it? Here we have 4 to 5 models. The first model we have here is the social network. It is an active multidisciplinary area where the study focuses on people, group of people, and different kind of relation between them. A graph can be used to model it, where the node are used to denote the people and the link are used for the relation between them. For example, here we have acquaintance. To make it simple, no directed link or loop are needed and simple graph is enough. Vertices are used to denote people or group of people and the link between them are used to denote their current status of being friend or acquainted. For example, we have Facebook or our world, etc. For example, we have a graph here where nodes or vertices represent people and the links between them represent their status of being acquainted or being friend. For example, the V1 is labeled as Noreen, V2 Rabia, V3 Fabia, V4 Vanya, V5 Anya, V6 Romina, V7 Amna, V8 Rafia. V1 is connected to V2 by E1. Therefore, Noreen is a friend of Rabia. V2 is connected to V3 by E2. Therefore, Rabia is a friend of Fabia, and so on. In the influence graph, a simple directed graph is enough to study the behavior. For the influence graph, a simple directed graph is used to study behavior, that is influence. In this graph, यहाँ पे We have a person A, a person B, person C, person D. पर्सन ए ने इन्फ्लुएंस किया है पर्सन बी ने इन्फ्लुएंस किया है सी ने इन्फ्लुएंस किया है डी को और ए ने ऑल्सो इन्फ्लुएंस किया है सी को। अगर आप नोट करें, बी सी डी इनमें से किसी ने भी ए को इन्फ्लुएंस नहीं किया। देयरफॉर बी सी डी आर इन्फ्लुएंस्ड बाय ए। A person A influenced the person B, C, and D, but cannot be influenced by any other person in the graph. Collaborator graph या collaboration graph. A simple undirected graph where vertices represent people from any industries, films, TV, or academic, and links represent collaboration. The second kind of model we have communication network. Number one is call graph. To make a call, we need a telephone number. Number one. The second point is during a call, a person cannot receive another incoming call because the line is busy. Every call is directed. We require a directed multigraph for it, where a vertex is used to denote telephone number and a directed edge for telephone call. Also, a two-person call graph can be unidirected. For example, we have V1, V2, V3, where V1 can make a call to V2, V2 can make a call to V3, V1 can also make a call to V3, V3 can make a call to V2, V2 can make a call to V1, V3 can also make a call to V1, E1, E2, E3, E4, E5, E6. Therefore, we have a directed multigraph. For two-person call, a single link is enough, where V1 can make a call to V2. Also, V2 can make a call to V1. Therefore, we have undirected graph. Now we have a model for software design. In this, we have module dependency graph. Our program is made up of many different modules, where a module is dependent on the other module. Our directed graph can be used to describe the dependency flow, where node denote the module and links for dependency. For example, the protocol is dependent on the main and the network is dependent on the protocol. The fourth one is precedence graph. In a computer program, it is good to know the dependence of a certain statement onto the other. The dependent statement need not to be executed first. To model it, you can use a directed graph where the vertex play the role of statement. If the statement 2 is dependent on statement 1, what you can do, you can make a link from statement 1 to statement 2 to define the dependency of statement 2 onto statement 1. In here, S1 is not dependent on S2, therefore we do not have a link here. But S5 is dependent on S1 and S4, therefore we have a link. The second one is road network. Graph can be used to model road network. Here vertices are used to represent intersection and the edges for the road. For example, you have a one-way road where the vertex V1 is used to denote the intersection, and the link between these two is denoted by E1, road 1. Since we have a one-way road, therefore E1 is directed. This road goes from V1 to V2. In the case of two-way road, the link E1 is bidirected or undirected. Our traffic can goes from V1 to V2 and also from V2 to V1. अगर आपके पास दो पॉइंट्स है, आप इन दो पॉइंट्स के दरमियान में ये आपने रोड E1 बनाई where traffic can goes from V1 to V2 and also from V2 to V1. Therefore, E1 is undirected. थर्ड कैटेगरी है यहाँ पे मल्टीपल वन वे रोड. यहाँ पे traffic is coming from V1 to V2 and also from V3 to V1. From V2, the traffic is going to V4. V1 से भी ट्रैफिक V3 से भी, दोनों ट्रैफिक यहाँ कंबाइन होंगे और वो फ्लो करेंगे फ्रॉम V2 टू V4. Therefore, E1, E2, E3 are directed. Multiple two-way two ways road. The first link is E1, the second one is E2, third one is E3, fourth one is E4. E1 is undirected because we have two-way roads from V2 to V4. E2 is also undirected. From V4 to V3, E3 is undirected. From V3 to V1, E4 is also undirected. You can also define a link between V2 to V3 or a two-way road between V2 to V3. E1, E2. E5 as one-way road. Now the graph is a mixed graph because we have two-way roads and also a one-way road between two-way roads. The fifth one is biological network. In this, we have protein interaction graph. An undirected graph can be used to model it, where the nodes are used for the protein and the link for the interaction between them. The graph is helpful in deducing important biological info, as by identifying most important protein for various functions and functionality of newly discovered protein. Since there are millions of protein, the complexity of the graph increases and it is often split into smaller graph called modules. In here we have a module where the nodes like RRP4, RRP43 are used to denote the protein and the link between them are used to denote the interaction between them. Graphs are also used to model tournament. Number one is round robin tournament, a tournament where a team has to play once with all the other team with no ties. A simple directed graph can be used for it. Where the vertices are used to denote the team. For V1 we have T1, V2 we have team 2, V3 we have team 3, V4 we have team 4. V1 has to compete with V2, or the team 1 has to compete with team 2, also with team 4 and with team 3. Team 2 has to compete with team 4, team 5. Team 5 has to compete with team 6, also with team 4. Team 6 has to compete with team 7, team 4, and team 7 has to compete with team 4, team 3. The second one we have single elimination game, where after single loss the contestant is eliminated. The winner of the game 1 move forward to play the game 2. Vertex can be used for games and a directed link used to connect first game with the second game where the winner of the first game is going to play. In this graph, V1 has to play a game with V2, and after winning a game, V2 can move forward. In the same way, V3 has to play a game with V4, and if V3 wins, then V3 can move forward to play a game with V1. After winning the game, V1 can move forward to play the game with the, let's suppose, V11.